Hello guys, welcome back to Learn, Do, Explain. This is the class for high school geometry, and in today's lecture we will introduce the equation of the line. Okay, so let's go ahead and get started. Okay, so we have arrived to lecture 31, the equation of a line, and the objectives for this lecture will be to define a line properties, and its equation. Utilize slope, intersect, and point slope to define the line equation and understand how to determine the slope. And finally, apply concepts to determine the line equation using given information. Okay, so we already know what a line is. We discussed that at the very beginning of this class. But now we're going to talk about the equation that defines a line in the coordinate system. Okay, in this lecture, we're going to talk about two types of equation. One of them is the slope-intersect equation, this one right over here. And the other one is the point slope equation, this one right over here. They both represent the same thing, is just the representation of a line in the coordinate system. So let's talk about each of them individually. The first one will be the slope-intercept equation. This equation says that y is equal to m times x plus c. What does this mean? Y is the y coordinate of a point in that line, any point on the line that we are defining. M is the slope of the line. Later on in this lecture, we're going to talk about the slope. M represents the slope of the line. X is the x coordinate of the same point in that line. This x is connected to this y. Y will be the y coordinate of the point, and x the x coordinate of this same point. And finally, C is the intersect with the y axis. Okay, so this will be the intersect of this line with the y axis. Okay, so some examples of the line equation could look like this. Y is equal to 2x plus 5. In this case, this is the y coordinate of any point in the line. X is the x coordinate of any point in the line, which line has 2 as a slope and intersects the y axis in 5 positive. Okay, some other examples of this slope-intersect equation of the line could be y equals to 1/3 of x minus 1. In this equation, y again is the y coordinates of a point. X is the x coordinate of a point in the line. 1/3 is the slope, and this line intersects the y-axis in -1. Okay, so you may be asking, okay, but why do I have y and x in my equation? Well, because let's say that we are given this equation, y equals to 3x plus 2, right? Where 3 is the slope. Remember that the slope is the one that is multiplying the x coordinate, and plus 2 is the intercept of that line with the y-axis. So given this equation, if I'm asked to make sure if the point 1, 2 belongs to this line, what I have to do is to substitute the x coordinate and the y coordinate into the line equation. How do we do this? As follows. We have the y coordinate in this point is 2, so we go 2 equal, right, because y goes with 2. 3, the same 3. X, what is the x coordinate of the point? Is 1 plus 2. And we need to make sure that this equation complies with the equality. We have an equal sign right here. and we need to make sure that whatever is on the left of the equal sign is the same as what is on the right of the equal sign. If we solve this equation, we end up with 2 equal to 3 times 1 is 3 plus 2 is 5. Is 2 equal to 5? No, correct? So what does this mean? That this point 1, 2, does not belong to the line which equation is y equal 3x plus 2. Let's do another example with this same equation. Now we need to verify if the point 1, 5 belongs to this line. Well, now we substitute the values. We have that 5 is equal to 3 times 1 plus 2. Does this satisfy the equality? Well, let's check. 5 is equal to 3 times 1 is 3 plus 2 is 5. And that is correct. 5 is equal to 5, which means that the point 1, 5 belongs to this line equation, to this line. What do I mean that belongs? Well, we have a line. Let's say that this is the line that we're looking for. And what I mean by belongs is that this point that we are evaluating is on top of the line that we are checking with the equation of the line. Okay, so remember that a line is a combination of infinite points, right? But a point located right here does not belong to this line, right? This point right here is not part of this line, but the point right here is part of this line. That's what I mean with belong to this line. So again, the line is a combination of infinite points, a line, but there are also points outside the line that they do not belong. And by do not belong, this equality will not be satisfied if the point is not on the line. For this equation, what we need to know about this line is the slope of the line and the y-intercept. If we know the slope of the line and the y-intercept, we could have the equation of the line. Why? Because if you see the examples of the equation of the line, the numbers that we have is the slope and the y-intercept. Okay, so let's see the other type of line equation. We have the point slope equation, and what this equation says is that y minus y1 is equal to m that multiplies x minus x1. Okay, so y1 is the y coordinate of a point on the line, m is the slope, and x1 is the x coordinate of a point on this line. So, but you may see that now we have y and y1. Well, this is because for this equation, we need to have one point on the line and the slope of the line. By having this information, we could write down the equation of the line, okay? So for this one, we need to know a point, any point on this line, and the slope. Remember that before we needed the slope and the intersect with the y-axis. Well, in this one, we need any point on this line and the slope of this line. With this information, we could create the equation of the line. Okay, so let's do some example. Let's say that I'm asking you to create the line equation that has the point 2, 3 and has a slope of 2. Okay, so the only thing that we need to do is substitute the values on the formula for the line. Okay, remember that this will be x1 and this will be y1. Okay, so the formula of the line according to point slope will be y minus y1 will be 3 equals to m, which is the slope, which is 2, that multiplies by x minus x1. Okay, this will be the equation of the line that contains the point 2, 3 and has a slope of 2. Okay, again, for the line equation, we need to have two unknowns, the y and the x, because based on this equation, we can verify if a point belongs to the line or not. Here we created the equation of a line that contains point 2, 3 and has a slope of 2. But now we were asked to check if the point 1, 2 belongs to this line that we just created. How do we do this? Well, now we substitute, this is x and this is y. We substitute this information into the line equation that we have and check if the equality applies. Okay, so y will be 2 minus 3 is equal to 2 that multiplies 1 minus 2. Okay, let's solve this. This will be minus 1 is equal to 1 minus 2, that will be minus 1 times 2, that will be minus 2. Is minus 1 equal to minus 2? No, which means that point 1, 2 does not belong to the line y minus 3 equals to x minus 2. Okay? So again, if we substitute a point, in this case 1, 2, into the line equation that we have and the equality is not satisfied, it means that the point does not belong to the line. Okay? Again, what does it mean that a point does not belong to the line? We have a line and points that belong to the line are the points on top of this line, the points that form the actual line, and points that does not belong to the line are outside. They are not part of this line. Okay, again, remember that a line is infinite, so it grows infinitely in both directions. Okay, so let's keep moving to the next part of this lecture.